Hi, I am Mr. Barr. This is the Math 8 goal number 8 functions pretest. I'm going to go over it with you. So make my head a little bit bigger. So here's our first one. This table shows the linear relationship between the number of songs downloaded and the total cost. Okay. What is the rate of change? What I'm going to do is I'm going to look at how did it change between these two lines. Well, it went up by +1, and let's add that plus to it. And then how did it change right here? Well, it went up by +99. Well, this is X, and this is Y, and we're looking at the change. It's basically X is the run, and this is the rise. So if I put it together as rise over run, the rate of change, which is another word for slope. Slope and rate of change are the same thing, is 0.99. There we go. This table represents a linear function. Create the equation in the form y equals mx plus b that represents the function. So I know that I need the slope and the intercept to make this work. Well, the slope, I just showed you how to do on the other problem. So let's go from here to here. That went up by 3. From here to here, it went up by 2. So my slope is 2 over 3. Rise over run. This is my run. This is my rise. So I have my slope. There it is. Y equals 2/3. But now I still need to get my y-intercept. Well, the y-intercept occurs when x is 0. So I look here. Do I have x equals 0? No. X equals 0 isn't here. But where would it be? It would be right here. And if x is 0, what's halfway in between -3 and 3 is 0. Well, what's halfway in between -3 and 1? -1, right? If I started counting up, that's what would be right in there. So I know that my y-intercept is right there at -1. An incomplete table is shown. Fill in the empty cells in such a way that the table does not represent a function. Explain your reasoning. Something is not a function if an x is trying to grab two different y's, right? If I see that happening, then it is not a function. So what I did here is I put a 6 right here. So 6 is grabbing 8, and 6 is grabbing 7, or maybe it's 6 is grabbing 9, or 6 is grabbing 10. But right here, that means it doesn't work. Anytime I see this, that means it is not a function. So, and what's my explanation? Since 6 is paired with 8 and 6 is paired with 7, it is not a function. Each x can pair with only one y. And this is an x pairing with two y's, not a function. Explain how the vertical line test works. Okay. If a vertical line crosses the graph in 2 or more places, then it is not a function. So here's an example. Here's this kind of curvy S line. I can draw a line through it. Actually touches in 3 spots, doesn't it? 1, 2, 3. If it touches in 2 or more spots, it is not a function. On the diagram below, draw arrows from the input values to the output values so that the relationship represents a function. Use as many arrows as you wish and as many input and output values as you wish. So I want this to be a function. So I had 2 going to 6 and 4 going to 6. That's okay. 2 is not taking 2 numbers, and 4 is not taking 2 numbers. And actually, that's a -6 anyways. Explain your reasoning. Each x is paired with only one y. Then it's a function. Oh, there's my reasoning. Each x is paired with only one y. Maria is driving to work. The graph below shows Maria's distance from home over a period of time. Explain what is going on each segment of the graph. So I'm going to write it here. I'm looking for BC, what's happening at BC. It also goes to my next page, DE and EF. DE and EF. So let's see what's going on with those. Let's zoom in a little bit. So the first one is BC. Well, let's look at BC. Right here, what's happening right there? Well, she's going away from home, away from home, away from home. What's she doing here? Coming back home, back home, back home, back home. So BC is going back home. What's happening here? Away from home, away from home, away from home. Then DE, what's going on right there? Her distance isn't getting any bigger. She's plateaued, which means she's parked or stopped. She's not moving. She's just sitting there. And then EF, away from home, away from home, away from home. All right. Determine if each function is linear or nonlinear. What I'm going to do is I'm going to plot all of these on a piece of graph paper and look at it and say, hey, is this a line or not a line? Here's my piece of graph paper. The first one, that is not linear. I know it looks kind of, nope, that's not linear. It's kind of doing a funny jog right there. That's not linear. This guy, I know it looks like it's kind of linear, but it's not. Let's put a ruler on that. This one right there. That's not linear. But this one. That one, yep, that's linear right there. And this guy, it's hard to see, but no, that's not. If I line those up, is that making a straight line all the way through? Nope. How about, no? That's not linear. So the only one that is linear is that third one. So nonlinear, nonlinear, linear, nonlinear. The table and the equation below represent two different linear functions. Here's the table. Here's another linear function. Enter the function below that has the greater rate of change. So I need to create the function for this. It's the same thing I did on one of the previous questions. First off, let's find the slope. I find the slope right here. What's the change here? Plus 1. What's the change there? Plus 2. I know this is the run and the rise. So 2 over 1, there's my slope. Now I need to go find my y-intercept. My y-intercept occurs when x is 0, and this is a nice table because it's right there. There's my y-intercept. So let's put that together. Slope, intercept, y equals 2x plus 1. Now let's determine which one's bigger. Well, this guy has a slope right there of 2/3. This guy has a slope of 2. Which one has the greater rate of change? This guy, 2 is bigger than 2/3, so that's the one with the greater rate of change. Okay, let's go on to number 11. Bertram and Patrick are walking to school. The distance on the graph is each student's distance from home. Bertram walked straight to school without stopping. Patrick started to walk to school, remembered that he forgot something, returned to his house, got the forgotten item, and then walked to school. So here we go. Bertram, walk, 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 farther away from home, farther away from home, farther away from home, farther away from home. Patrick, walk, 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 uh-oh, forgot something, walk, 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 going back home, gets his thing, walk, 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 something like that. I guess theoretically you could put like plateaus in here as he's actually at home looking for it, or right here maybe he stops and thinks for a minute, but something that looks like that. You could have a plateau there, but I would accept either one. Cool, that's it. Thank you for watching.